Have you ever gone for a long run or walked all over town running errands, only to end up right back where you started? Well, what if I told you that in the world of physics, you might not have gone anywhere at all? How is that even possible? It all comes down to the huge, and I mean huge, difference between two little words, distance and displacement. To really get our heads around this, let's start with a super simple everyday situation. We're going to call it the round trip puzzle, and trust me, it's the perfect way to see these two ideas in action. Okay, so just picture this. You leave your house, you walk down the street to the local shop, maybe to grab a coffee, and then you walk straight back home. So here's the big question. Have you actually gone anywhere? It sounds like a trick question, right? But the answer, and this is the cool part, completely depends on how you measure your journey. So let's start with the first way to measure this trip. This is the one that's probably the most obvious, the way we usually think about it. It's all about measuring the path you took, where every single step you take matters. In physics, we call this distance, and really, it's just the grand total of the entire path you traveled. The best way to think about it is like the odometer in your car or the step counter on your phone. It just keeps adding up, tracking every bit of ground you've covered. It's just a number, like 10 meters or 5 miles. There's no direction involved, which is why in physics we call this a scalar quantity. Okay, back to our story. Let's say the walk to the shop is exactly 5 meters. That's the first part of your journey. Then you turn right around and walk those same 5 meters to get back home. So to calculate the total distance, it's about as simple as it gets. You just add the length of each part of your trip together. And boom, that gives us a total distance of 10 meters. Super straightforward, right? Your fitness tracker would be very happy with that. But remember, that's only one way to look at it. Now we're going to look at that exact same journey from a totally different angle. Think of this one as the straight line shortcut, where we only care about two things, the start and the finish. And this brings us to displacement. Now, this is where it gets really interesting. See, displacement completely ignores the scenic route you took. All it cares about is the shortest, straightest line from your starting point to your ending point. Think as the crow flies. And what's super important here is that displacement is a vector quantity, which is just a fancy way of saying it has both a size, like 5 meters, and a direction, like east. So let's apply this new rule to our little trip. Where did you start? At home. And where did you end up after going to the shop and coming back? Also, at home. Okay, so here's the key question. If your starting point and your ending point are the exact same place, what is the shortest possible straight line distance between them? The answer? A big, fat 0. That's right, 0 meters. As far as displacement is concerned, you haven't moved an inch. And that is the solution to our puzzle. The same journey can be 10 meters long and, at the exact same time, 0. It just depends on what you're asking. So we've got 10 meters for distance and 0 meters for displacement. Now let's put these two ideas head to head to make sure the differences really stick. If you're going to remember one thing, make it this. Distance is the total path traveled, all the twists and turns. Displacement is just the shortest straight path from A to B. Let's break that down just a little bit more. All right, let's look at this. First, the definition, total path versus shortest path. Got it. Next up, direction. Distance couldn't care less about direction, but for displacement, it is absolutely essential. That's why distance is a scalar, just a number, while displacement is a vector. And finally, can it be 0? Well, if you've moved at all, your distance can never be 0, but your displacement, oh yeah, it absolutely can be, as we just saw. Now you might be thinking, okay, that's a cool little brain teaser, but does this actually matter? And the answer is yes. This isn't just a word game. Understanding this difference is super important in the real world. I mean, think about a runner on a 400-meter track. After one full lap, their distance is 400 meters. But since they end up right where they started, their displacement is 0. Or think about your car's GPS. The winding road you actually have to drive, that's the distance. But that straight line it sometimes shows from you to your destination, that's the displacement. It really all boils down to this one simple idea. Motion is not just about moving, but about how far and in which direction an object moves. See, distance tells you the how far part, but displacement tells you how far and in which direction your overall position has changed. You really need both of them to get the full picture. So I'll leave you with one last thing to chew on. Think about your own day as you're planning your commute or running errands. Which one really matters more to you? The total distance you have to travel, or your final displacement at the end of the day? It's something to think about.